Let's talk about division. I'm going to set up an analogy between what you know about dividing integers and what you don't know about dividing polynomials. So back in elementary school, when you were dividing integers, if you were lucky, the division came out evenly. So 9 divided by 3 is 3. And in our class, if you're lucky, when I give you two polynomials to divide, you can factor them so that they divide evenly. If we've got this polynomial divided by that polynomial, you can write this as x plus 1 times x plus 3. And now you see that this divides out evenly and that the answer is x plus 3 with no remainder at all, because those two divide each other to be 1. Just to make the analogy really strong, here you already know how 9 factors. 9 can be written as 3 times 3, and then the two 3's divide each other to be 1 to make a 3. So that's what's happening. The structure, I hope you see, is the same. Every number can be broken down into, so every integer can be broken down into smaller factors. Every polynomial can also be broken down into smaller multiplied factors, which you can then potentially divide out to get your answer. Okay, so what if you're doing 10 divided by 3? That doesn't divide evenly. But if you were going to break this into pieces, you could imagine it as 9 plus 1 divided by 3. And then you could break it into two terms, 9 over 3 plus 1/3. And now this does divide evenly, and so that you know the answer would be 3 and 1/3. A different way of thinking about it would be the largest thing that 3 can multiply to be that's smaller than 10 is 9. So 3 times 3 is 9, but then you'd have 1 left over. So in elementary school, you might say 10 divided by 3 equals 3 with a remainder of 1. But what it means to have a remainder of 1 is that you are adding like a remainder of 1/3 because you were originally dividing by 3. And it sort of makes sense because if you multiply both sides by 3, now you've got the original thing that you were dividing by is the same as 3 times 3 plus 3 times 1/3. So this gives you the 9, and here these cancel to give you the 1 remaining. So 10 is 9 plus 1. So again, all of these ideas about the structure of multiplication and division apply directly to the structure of multiplication and division for polynomials. So what if we were to change it a little bit? Instead of x squared plus 4x plus 3, what if we added one, x squared plus 4x plus 4? And that's just like what we did over here, where I had 9 and I added 1 to make 10. Well, if you knew how I'd produced the problem, an answer might occur to you. We could do the same thing that we did here. Let's break the polynomial apart into two pieces, one which factors nicely and the other which is a remainder. So let's break it into pieces. We've got x squared plus 4x plus 3, which we know factors nicely, but then we've got the 1 on the outside. And these two numerators are the same because all I did was I took the 4 and I turned it into 3 plus 1, which is the same thing. Okay, so how does this work out? So now I've got two terms. I've got this term and I've got that term. So here I've got the x squared plus 4x plus 3 divided by x plus 1. And then separately I've broken out the 1 over x plus 1. So this we already know factors nicely and divides. So this is equal to x plus 3. And then I've got 1 remainder. But because it's a remainder, it needs to be divided by the original thing you're still dividing by. So this suggests a general possible way of doing the polynomial division. It's sort of like completing the square almost. What I need to do is I need to break the polynomial into two parts. One part, which is going to have x plus 1 as a factor, and then the other part is whatever it needs to be so that the numerator is the same as it was before. So I took my 4 last time and I split it into 3 and 1 because that's what would allow me to have one piece that has x plus 1 as a factor. Remember that for integer division, you can have like literally anything divided by anything, and it's going to give you an integer solution plus some remainder. And the same thing is true for polynomial division. You can have any polynomial divided by another polynomial, and it's going to give you, as a result, a polynomial solution plus some type of remainder. And so that's what we want to try and narrow in on, is how can you think about that? So let's go ahead and arbitrarily change the problem. Let's change the x plus 1 to be x plus 5. So that seems very unrelated to how we originally created the problem, so that it would be like very close to something that divides evenly. And I don't know, let's change the plus 4 to something else. Let's make the plus 4 be like plus 1, I guess. Here, I'm going to write it big so that we can do it carefully. All right, so remember, we want to turn this numerator into something that has x plus 5 as a factor. But we need to have some type of remainder term so that the two numerators are the same, because we can't just change the whole problem to make it factor nicely, because now it's not the same as the original question. Okay, so if you've ever completed the square, this is sort of like completing the square. The trick is, we want to think, let's ignore the constant for the moment. Let's figure out how could we find two things that will multiply to give us just the x squared and the 4x. And it's going to give us another constant term, but we're going to fix that later. So if it's got an x squared, I know that has to be x, because x times x is giving me the x squared. What I have so far is going to give me 5x, and I have to add something related to x to give me 4x. So there's really only one answer that works. If I already have 5x's, I have to subtract 1x in order to get my 4x's. The problem here is when I multiply this out, it's actually going to give me negative 5 as the last term. So here, let's write it out this way. So this is the same thing as x squared plus 4x. Yay! Except I've got the negative 5. Boo. So what I need to do is I need to add something on the outside that will turn the negative 5 into a positive 1, so that the two sides would be equal. A different way of thinking about it is, if I was going to multiply this out, I'd have something that's not quite the answer, and I need this to balance out with the negative 5 to give me what I started with. So this has to be plus 6, because plus 6 is the only number that will give you 1 when you add it to negative 5. Okay, so we've done it. But it might seem, and then this is all still over x plus 5. But let's sort of look and see what we've done to compare to last time. Last time, if you remember, last time we took our constant, which was 4, and we broke it into two parts. We had plus 3 and plus 1. This time, we have the constant 1, and we broke it into two parts. 1 is the same as 5 minus 6, and breaking it up that way has made this piece be factorable, and this piece is the remainder. So to finish the problem, when I factor this piece, it's not a surprise because we solved it to be this way. This factors as x minus 1 over x plus 5. So now this part divides. And then as a remainder, we've got minus 6 as the remainder, like this. So this divides, and you have that this polynomial divided by that one is equal to x plus 1 minus 6 over x plus 5. Let's arbitrarily change it one more time, and you can do one just for practice. So let's change this to x minus 2, and let's change this back to, or I don't know, let's make this one be 5. Okay, so give it a try. Think about, what do all these things need to be? And then in the end, it's going to equal some polynomial plus some remainder over x minus 2. So try and work it out the rest of the way. All right, so I know I want x minus 2 to be one of my factors because I need to be able to divide eventually. So I know this is going to be x because this is the coefficient on x squared is 1. So if I've already got negative 2x's, what do I need here to end up with 4x's? And the answer is 6. And then this is going to produce negative 12 here on the outside when I multiply it all out. So how do I get from negative 12 to positive 5? It seems like I've got to add 17. And let's just double check that that makes sense by multiplying it all out, okay? So here I've got x squared minus 2x plus 6x is 4x. And then here that's minus 12. But then when I add the 17 to the minus 12, that gives me plus 5, which is the same as what I had over here. So I've really taken this polynomial and I've split it up into two parts, one that's factorable and a remainder. So what that means is now I can split this term and this term. Here, the x minus 2's divide each other to be 1. So I've got x plus 6 with a remainder of 17 divided by x minus 2.